welcome everybody and good afternoon. In the next 2 hours, we will talk about the SoBigData research infrastructure. And the next 2 hours are organized in the form of a tutorial. You will get an overview and then some hands-on speeches about the research infrastructure. So this tutorial has been organized as a synergy activity between the Humane AI Net project and the SoBigData project, which is also a research infrastructure, of course. I think that without further ado, we can start. The first speaker is Roberto Trasarti, that will give you an overview of the SoBigData project and its ecosystem for ethical social mining.
So thank you, Chiara. Thank you to give us the opportunity to show to HumaniNet people SoBigData. And I'm Roberto Trasarti, and I'm the coordinator of the SoBigData project. And as you said, I will try to give you an overview of what is a research infrastructure in general and the reason why we started this project. So those are the speaker, and you will see their faces during this tutorial. But let's start saying that SoBigData started at the beginning with an idea. I mean, in order, let's say, more than an idea, the objective or answering to a question of, that rises from several research institute in Europe. So the problem was that there were a lot of existing technologies, existing platforms providing services for researchers, but actually those services were spread around several infrastructure, several technologies, and pretty much difficult to reach, to access to them. So the idea was, let's start to think about an ecosystem where we can integrate our expertise, our product, research product and give an easy way to access to those services to all the other researchers in Europe. So, and let's do this with an ethical framework, let's say. Let's integrate those services, thinking also to the ethical values that we want to preserve, let's say, then in doing experiment with those technologies. So at the beginning, I mean, the first SoBigData project was in 2015, and we were 10 institutes. After that project, we started the second project called the SoBigData and now we are 31 partners. So we spread a lot around Europe, mostly including in the new consortium many different actors in different disciplines. I mean, in order to reach those communities which may need to use our tools. So if in the first project we were mostly computer scientists, now we are computer scientists with economic people that study economics or sociologists, whatever. So from health, etc. So as I said, the idea is to combine data-driven and model-driven analytic approaches in order to answer questions like what is, what if, with the tools provided. The general idea of the research infrastructure is that providing an easy way to access to data and methodologies, we enable researchers in order to do experiments, define workflow of analysis, and keep in contact with researchers inside our consortium. And this, let's say, this combination of factors will lead to new experiment and usually also to new data or new methodologies that can be used again by others, other researchers in the future. So the idea is that this sort of virtuous loop of research will increase more and more the availability of tools and data inside the infrastructure. In our consortium, actually, we have 6 ERC grants. So this, let's say, help us in having excellence, let's say, in our research infrastructure. Clearly, everything that I said for now are, let's say, agnostic from the point of view of the research field that we where we operate. This is true in general for the research infrastructure. We are not limiting, let's say, our activities in specific fields, but it's also true that we sorry, we are collecting, let's say, expertise from various researchers in Europe, and we are aggregating them into these those vertical contexts that we call exploratories. Those vertical contexts are sort of containers where we develop new methodologies and provide new data, and we are trying to organize the work in these exploratories in order to answer to real question as much as possible to let's say improve the impact that we have in society. For example, in societal debate and misinformation analysis, we study more the opinion mining, the text analytics for understanding social networks, behavior, individual and group of people in social media. Demography, economy, and finance is more about the study of the territory and trying to identify factors or KPIs in order to describe the actual situation of a country. Sustainable city of citizen is more about the mobility of people and the fact and how to manage a city in order to give a better life to the citizen, and in the other way, in order to understand better the behavior of people. Similarly, immigration study, we analyze more the movement between countries. So in a macro level, perspective, and so migration from third world country, but also migration of brains, for example, between countries or researchers. That's finally we have this social impact and AI and explainable machine learning, which probably is nearer your topics. That it's in general the study of biases in machine learning or technology, or understanding the impact of specific tools to in society, specific intelligence AI tools in society. We have also sport data science, which is an exploratory about the indicators of success or prediction of injuries, for example, of players in the specific sport. And I mean, it's not in this slide, but actually it's pretty new. We have also an exploratory in health and biomedicine for the understanding the interaction between drugs and I mean pathologies or other factors. So with those exploratories, I mean, as I said at the beginning, we in SoBigData we have also a committee, an ethical committee, which evaluate all the experiments that is done inside SoBigData, in order to ensure that the ethical aspects are considered since the beginning of the analysis, and helps actually the researcher in order to get ethical approval even in their institution, because it's very difficult sometimes to obtain or to speak with ethical committee in the various institutions. And I mean, we give also support in order to, let's say, solve trivial problem or solve problems before going to the actual committee in the institution of the people that doing experiment with us. This will help a lot people in getting a fast acceptance, let's say, for their paper or their experiment. I said I'm speaking about people doing experiments also because I mean, we are not only the experiments that we do in SoBigData is not only inside the SoBigData, but also from outside with the service that we provide, which is the transnational access. I mean, the transnational access is the possibility of other researchers to reach one of our node and do experiment with us, and we give we pay actually the travel and the stay for those researchers. So we are trying to attract also other researchers in Europe in order to increase, let's say, the community, because I mean, at the end, the research one of the main objectives of the research infrastructure is to create a community around it, active community around it. So let me finish. Yes, let me finish with saying that we have SoBigData at the moment is interconnected, let's say, with other initiatives in Europe with at several levels, in the sense that we are interconnected thanks to the D4Science platform, which is the technology where we are based on. So we are connecting. We are connected to other platforms like other service provider like OpenAir, AGI, Zenodo, and more important, EOSC, the EOSC hub. But also we are interconnected with other research infrastructures. We know that we are not the only one. For sure, we are not the only one. So following the idea of European Union to go toward a unified, let's say, research infrastructure, we are interconnecting our services to other research infrastructure in other even in other fields like ERI, which is about Holocaust and Holocaust, so very different from our research infrastructure. But the fact that we can find the services of each other, it's one of the objectives. Finally, as you know, we are interconnected also with several other projects, European projects like Humanities, which where we share, let's say, knowledge and tutorials like this in order to, I mean, reach a common goal, let's say, in some sense, to have an impact in Europe. So I almost finished. I don't know if there are questions, or otherwise Valerio will describe you better the actual services of SoBigData, and not only, let's say, high-level description as I have done. Valerio, entra.
Okay. Thank you, Roberto, and I'm going to show you some services. No, maybe I share the the wrong screen. Here it is. This is one. This is the right one. Well, you could show. I will launch and full screen. Well, SoBigData. I present before to present the services. I am Valerio Grossi from CNR. I'm a colleague of Chiara and Roberto, and I am the project manager of the SoBigData project. In this presentation, quite short, I will try to give you an overview of all the services provided by our research infrastructure. Our catalog is a rich catalog of services. We divided these services in two main categories. What we call the online services are the ones related to internet tools, to services that can be easily accessed by online tools. On the other side, we have on-life events or services where it is required a direct interaction with people, and the main aim is to meet people. Unfortunately, due to COVID, we changed a little bit the nature of this kind of services and events, but the nature of these services remains the same. The idea is to meet people together in order to incentivize the different aspect of our research infrastructure. I started, essentially, Roberto already introduced the scientific part of our project that are related to exploratories. In our catalog, you can find all the products related to our exploratory. I'm going more deeply in detail with the main aims of the catalog. Through the catalog, you can find everything. All the products are inside our research infrastructure. That can be dataset, methods, application, experiment, and publication. There are a lot of ways to navigate our catalog, for example, by types or by exploratories, as you said before. And you have a lot of tags that you can click in order to find, in order to refine your search item. I want to highlight that everything inside the SoBigData are based on fair and fact principle, and all these products are available. And when we cannot share it freely, we provide all the information to access, or all the way to access the item you need to access. I cannot. Here it is. Well, another services that we have is called the SoBigData Lab. SoBigData Lab is a virtual research environment that enables the user to write an experiment, to write a method through JupyterHub, enable the user to execute an experiment that is already integrated into our engine, and of course enable the user also to integrate a new method into the engine. You will see the use of JupyterHub with the next presentation from Giulio, but in this short introduction, you have only to observe that you can also run an existing methods without any computer science skills and so on and so forth. Everything is integrated, or you can integrate a new method and make it available for all the people or all your community without any additional effort or additional cost. In the next presentation, we will see an example like this, where inside our research infrastructure we have specialized one workbenches and libraries that you can find only accessing our services. Well, I concluded the part on online. I start with the on life kind of services. The first services that we want to highlight is the transnational access. Transnational access is a service that the European Community required, asked to us. And the idea is quite simple. We go out with a call, and some people can apply to this call for scientific mission, short, of course. We cannot support long scientific mission, but in this case, our project is able to support 8 weeks at least, at maximum, of visiting. Is completely the costs are completely covered by our project, and the user can find can access to some data set that are not freely available, can run experiment, and can interact with our local expert, the local experts that are shared among the different host institutions along Europe. And if somebody is interested, can find a lot of information in our web page. During these years, we have a lot of application, and we supported almost 70 applications. Now the new call is opened in June, and we hope to start to host new visitors in January. Also, always monitoring COVID situation. Another aspect related to promote our research infrastructure is related to company, to involve company in our research, and on our side to try to transfer the knowledge from research to company. In this case, we have promoted the first edition of SoBigData Challenges. Is a services where we propose to small and medium enterprise to challenge us and promote and ask to us to solve some problem, or to contribute, or try to say something about a problem that a company can have. The edition of 2021, it's over in October, and now we have the final event in 2000 of November. Also here you can find all the information for participating to this event in our webpage. During this year, we supported 17 applications for this kind of services. Well, it is not over here about the services, because our part is the training and dissemination events. The training events we propose in 2020, we proposed a datathon. We will have another datathon in 2022 at beginning. We will have the official definition in the next days. And of course, we try to promote computer science also through some schools. In this case, the last one was in Scuola Normale here in Pisa, was related to machine learning and dynamic processes. And we promote the use of SoBigData platform through tutorial, or we organize completely, we organize entire conferences, such as the last one was SoCinfo in 2020. For example, the next summer school will be in 2022. We will have 2 summer schools related to our exploratories, to our research area. Also in this case, you can find all the details in our site. I don't want to lose too much time. Oh, sorry for the call. Switch off the phone. I wanted to close with some numbers. Numbers are obviously good for us. We have a lot of users of our research infrastructure. We supported more than 60 transnational access users, but we are an impact also in scientific production. We have more than 80 journal papers produced in this year. And for example, for the catalog, we have 92 datasets and more than 100 methods and applications. And well, I think we are in time to leave the floor to the next speaker. And as you said from the words of Roberto, we are an ecosystem and we want to have an impact in the European landscape. And finally, we promote a sensible and democratic way to use data and to produce science in all the perspective and all the direction science is expanding. Last but not least, SoBigData is entered in the ESFI roadmap, and this enables to us to have a good perspective for the future. Essentially, this is a European way to guarantee the sustainability of promising research infrastructure we are entered, and so for European community we are not promising but really more than promising. So I invited all the people to visit our site for all the info, to keep the updated info. I don't know if there are questions.
Seems that there are no questions. So Roberto, Valerio, thanks a lot for these introductory talks. And I think now it's clearer to everyone why SoBigData++ and Humane AI Net can benefit from each other. So while in Humane AI Net, the focus is more on connecting together excellent centers, SoBigData++ is a well-oiled machine that is been running for years, a platform that supports data sharing, method sharing, where you can run your own experiment, leveraging the platform and the computational capabilities. So I think that this is a good opportunity for of course, all the participants to these tutorials, but also for in general, for the Humane AI Net partners. Okay, so now we move on to more hands-on talks, and we start with Giulio Rossetti.
Hi, thanks.
Hi, Giulio, the floor is yours.
Oh, thanks. So let me share the screen. So here it is. Can you see my my Chrome browser? Yes. Okay. Perfect.
We do.
So just to introduce myself, I'm Giulio Rossetti, as Chiara, as all the other speakers of today, or most of the other speakers of today. I'm from CNR and a researcher here, and I'm the responsible, basically, the work package leader for the integration of methods and dataset within the SoBigData catalog and research infrastructure. So basically, what I would like to share with you today is a brief, very brief and succinct description on how to use our methods, or some of the methods that we developed, by basically showing you how we customized a Jupyter Hub instance with our libraries and all the libraries that are usually needed to do some data analysis. So just to start, what you can see here in my screen is just the SoBigData++ website. And this is important because I would like to show you exactly where to find the methods, where to find the catalog, and everything that is related to the research infrastructure online. So starting from this is the main page. What you have to search here is under Gateway. So you have the catalog, the workspace, and the lab. Just to provide you a little brief hint on what is here. You have already discussed with Valerio about the catalog. Catalog is just, as you can see, a list of the items that we have. So basically everything that goes from the data set to the methods to papers to learning materials. So these are just, how to say, a collection of data and metadata describing them. And it's the first step to have something integrated within our research infrastructure. But this is not exactly the focus of today's call. This is just to show you how to access the data and the method, and to see which methods are already integrated in a way or in another within the research infrastructure. What is important for today are other two aspects. In particular, are the workspace and the lab. The workspace is something that is tied directly. Let me check. Okay, I don't know why it's okay. Is something that is tied directly with the users that is registered to our platform. Basically, to access all the services of SoBigData, you have to register or to use your credential from an associated environment. So as already Roberto have shown in this presentation. And once you have registered within the platform, you will be prompted to basically load your files or store your files in your own workspace. As you can see here, there is mine, basically, in which you can see a few folder containing data or notebooks or something that is related to all the activity, the research activity or tutorial activities that I'm doing with this platform, okay? So one thing that you can do is just upload your data here, for instance, if you would like to work on them, or save here and download from here the notebook that you are developing within the Jupyter Hub of SoBigData. Why is this important? This is important because, coming back to the tutorial of today, if you would like to follow my step or repeating them in a subsequent time, I've prepared for you this repository with all the code and the data for today's tutorial, okay? So if you reach this URL here on GitHub, Giulio Rossetti, Human AI Net, SBD tutorial, you will find basically all that you need today to replicate my exercise of today. So you will find the data, you will find some notebook that we will see in a while, and so on and so forth. What you have to do is register on the SoBigData RI, upload this data, this folder within your workspace, and then follow basically my step on the lab, okay? So this is just, how can I say, a first starting point to repeat what I will do today, but it's not mandatory that you will do right now. Just be sure that you can repeat everything whenever you like. So let's come back to the main page of SoBigData for what is the very core of today's talk. Since from Gateway, you can reach the lab. So as you can see now, I'm already logged in. So this is what happens when you are logged in a system, what you will see in the lab. You will see basically this main page. We will show you all the specificity of the research environment that we have built within SoBigData. So as you can see, there are a few ways to run experiment here. There are principal two ways. One of the first that we will see today is the method development. That basically is a Jupyter notebook, Jupyter Hub instance that has been developed and customized for SoBigData, and that is shipped with a set of libraries, Python libraries that are already pre-configured to be used. So without installing anything, you will find, for instance, our libraries for network science, for mobility, for explainable AI, for visual analytics, and so on and so forth, already there, ready to be used, okay? And this is this topic that we will cover today with three different examples of libraries that we developed. One for community discovery, so network science, another for modeling and running experiment for epidemic diffusion and opinion dynamic diffusion, so still something tied to network science. And finally, we will see very short a notebook on how to use scikit mobility. It is a library devoted to basically study human mobility. Okay, so we will see three different examples of libraries that have been developed within SoBigData that are already available there. As you can see here, there is a list of libraries that are already shipped within our method development, so within our Jupyter notebooks, but they are not the only one that will be there in the future. So there are plenty of libraries that have been under development, others that are already pending for the integration. So these are just the ones that are already there available, but plenty of them will become in the next future. So for instance, we have an explainable AI library that's under development, one for privacy. We have another one that covers basically visualization. So there are plenty of different topics that will be touched by libraries developed within SoBigData. And the second way to run experiment that will not be covered by my talk, but is another very important side for the research infrastructure, is the method engine. The method engine is, how can I say, something like an abstraction with respect to what Jupyter Notebook offers. So if in Jupyter Notebooks you have to write your own code, maybe using our libraries to develop your algorithms or carry out your analysis, Method Engine provide an interface that is code-free. So basically you will have several methods, not necessarily the same, that are shipped within the Jupyter Hub, that will provide functionality that can be called directly by some GUI interface. Okay, so basically we have, for instance, let me show you just very quickly the idea. You will have some customizable tools, for instance, for representation learning, for text analysis, in which we have just to select the file, fit the parameters, and run the experiment without writing any line of code. Okay, this is more or less the idea. So as you can see, there are two different ways to carry out experiments. One is more for programmers, for research that are from computational science that has some expertise in writing code, and the other, to some extent, simplify the development of experiment and allow to be used, the research infrastructure to be used also by non-specialists in writing code, not computer sciences, basically. So let's come back to our main page. Let's move now to the method development. So to the three tutorials, small tutorials that I've prepared for you today. So clicking on method development, you will be prompted by this interface. This interface basically allows you to select one of the different virtual server, let's call this way, virtual machine that are designed to run your experiments. So you can either choose to have a very bare bone configuration with a standard machine with 2 GB of RAM and 2 cores, or something a little bit better, so to say. There are plenty of choices here. Some of them I think will have been disabled for some reason, but still, the idea here is that you have to choose how big your machine should be for the experiments that you will need to run. Okay, so for today, we can just start with the default standard and click start and wait for the machine to be spun. So as you will see in a while, we are just waiting. Okay. The Jupyter instance that we have has been pre-configured to support a lot of different languages, starting from Python, of course. Most of our libraries have been developed in Python, but also, for instance, given support to Julia, to R, to Kotlin, to a lot of different programming languages. So you are not restricted to Python to writing code or perform your experiments in SoBigData. And for now, let's focus, however, on Python, since most of our libraries are written in this language. As you can see here, it's just a standard Jupyter notebook. You have your Jupyter Hub notebook. You will see the list of the folder that are present in your workspace. This is the workspace, my workspace that I showed you before. And for today, I will show you these three, or at least I will try to show you all of these three small notebooks here. Let's start with the first, CDLib. CDLib is a community discovery library. So a library that is completely designed to provide an easy access to algorithms that take a network in account and try to cluster it in groups. Basically, they try to break down a network tissue in components, in connected components, or in densely connected components. So to identify subset of nodes that are strictly connected with each other and loosely connected with the rest of the network. So there are plenty of algorithms to do so, and CDLib is as of today the most used and biggest library to do this kind of analysis. It's shaped with more than 80 different algorithms, both for static and dynamic networks. I think that that is important to mention. All the libraries that have been developed within SoBigData++ and early within SoBigData have their own project on GitHub, so they are freely accessible and open for contribution. And also they have the documentation linked within SoBigData, usually on Read the Docs or similar services. So everything is documented, everything is openly accessible and inspectable. So coming back to CDLib, I will not dig deep in the code. I will just provide you a little bit of an overview on how to use it and what are the functionalities. So here the idea is that CDLib can be easily imported as a standard Python library, and it will allow us to use any kind of graph model object provided by the standard library in Python. So you can use, for instance, as a data representation, network X, network kit, or iGraph object or graph tool object, everything. The library basically will transform for you the representation in what is needed by the algorithm of your choice. Then it will allow you to run the algorithm, obtain the results, the clustering results, and then perform a little bit of analysis on the results of the clustering. So as you can see, for instance, here, there's a very simple function to load the data of a network. Here, for instance, we have a network built on the characters of the first season of Game of Thrones. Then we can apply on this graph a few algorithms for community discoveries, for instance, classical level propagation on Leiden. And then on the obtained communities, we can basically access some field that will report some metadata on the obtained clustering, for instance, the name of the clustering used, the parameter used, and also, of course, the communities of nodes that are present within the network. For instance, this will be a representation of the community identified by Leiden. This will be the first community, this the second, and so on and so forth. So as you can see, just with a single line of code, the algorithm will be able to extract the community for you and then make them accessible for further analysis. Of course, this is not the only thing that that happens behind the hood of when invoking an algorithm. We will have also some statistics for free on the clustering. For instance, if the clustering is overlapping, meaning that a single node could belong to one or more communities at the same time, which is the coverage of the nodes, if some nodes lives outside a partition or not. We can have something like an output to a JSON format to save the results. And also we can have the chance to apply some evaluation function directly on the clustering object to get some insight on the goodness of the partition. So in this case, we can get some statistic on the internal average degree rather than the modularity, rather than the conductance, and so on and so forth. We have something like 30 to 40, I don't remember exactly, quality function for clustering already implemented that are invocable easily with the same syntax, providing a standardized output. Of course, the same thing can be performed even while comparing different clustering obtained on the same data. For instance, here we have the Leiden communities and the label propagation communities obtained on the network from before, so on the Game of Thrones network. What we can do is just apply a few similarity function that will tell us how similar are the two partitions among them. Okay, so here we have something like 10, 12 different similarity scores, and this is something, for instance, to understand how the different algorithms are working on the same data. Of course, the library also comes with a visualization facility. So if your network is not so big, you can visualize the network and assign different color to each community to visualize the different cluster directly. Or, and here, for instance, we have for the same network visualization for the cluster for Leiden and for label propagation. As you can see, there are different colored clusters within the same network. Or if your network is quite big and you're not able to plot as a whole, you can have a similar visualization by collapsing community in meta nodes. So here basically is a simplified graph in which each node is a cluster of nodes, and the link represents links among different clusters. So you can see how the modular structure of the network is how can I say, organized within a higher scale, so to say. Of course, here the same Leiden and label propagation. As you can see, just a line of code to visualize, to generate the plots. But this is not the only kind of visualization that we can provide. We can also provide some visualization that are a little bit more statistically related. So for instance, we can have visualization of distribution, for instance, as the variant plots here are showing for the two clustering, the distribution of internal edge density, for instance, or we can have scatter plot comparing two different features computed on the clusterings. For instance, here are the size of each individual community and its internal average density. So we can see, for instance, that in lab propagation we have a very big community with a very, very low edge density rather than what we can observe in latents. Okay, so this is just comparative analysis. And we have plenty of this visualization, even other that takes into account, for instance, for dynamic network, the evolving in time of the community's structure in the graph. And apart from that, we can also have some function to evaluate against ground truth. So for instance, if we already knew which are the real partition of our graph, we would like to understand how a given algorithm is able to what extent is able to retrieve this partition. We have several ways to do so. We have already implemented a few models that provide synthetic networks, synthetic benchmark with a planted community structure, so to evaluate in a fair way different algorithms. And we have visualization exactly for that, as well as visualization like this that allow to abstract, so to say, the similarity of different clustering on the same network in a very, very simple and easy to understand way. Okay. So as you can see, this is a very big and complete library, and is like all the other that we already have implemented. So this is an idea. So our libraries, or at least the one that I will show you today, are structured in a way to perform basic large data analysis, extraction of information, applying some kind of algorithms, then statistical analysis and visualization of the results. All of them are complete monolithic block that basically approach a specific problem from top down. So let's see the second one, still for the network part, still devoted to network science. This is Untitled, similar name to the other because it's just the predecessor of the other for another topic. So Untitled stands for Network Diffusion Library. And basically this library is designed to perform what-if scenario applying well-known epidemic modeling to network test context. So for instance, to simulate the diffusion of a virus or an idea, or also to apply opinion dynamic models. So opinion dynamics in order to study, for instance, in a network population, how individuals will change their mind by peer pressure or by, I don't know, discussing on a given topic, given their open-mindedness also in similar attitudes, okay? Of course, the library does not only allow you to provide, to execute an existing method, there are plenty of them already implemented, but also to implement your own method with a very, very simple syntax that can be applied either on a programmatic side, so writing exactly Python code, or even by a descriptive, using a descriptive language that is NDQL, that basically is a SQL-like language that allows you to describe a model and the data and run the experiments. Consider, for instance, that recently for Halloween, we have some external contributors that provided us with models that simulates a zombie apocalypse in Untitled. So basically, it's very flexible and it can be used to model any kind of diffusion process. For instance, diffusion of zombies, something like that. So like CDLib, here the idea is to start from network creation. It supports even here network X, iGraph, Graph2, and so on and so forth. Then apply a model and configure a model on the given network and run the experiment and visualize the trend of the diffusion. So for instance, let's start with a very simple family of models, compartmental models, SI, SIS, SIR, which are classical models in epidemiology that are used to model, for instance, the diffusion of flu or any kind of pathogen. And let's see how they can be used within network X and Untitled, sorry. So let's start with, after all the imports and the building of a random graph in this case, let's start with the SI. SI is basically a model in which we have two different statuses or to which node can belong, susceptible or infected, and the node can transit from susceptible to infected if it is in contact with an infected one and given a certain probability. Okay, so what we have here as a parameter is this beta parameter here. That's basically the probability of move from susceptible to infected if at least a neighbor is infected as well. And then we have a parameter that specifies the percentage of infected nodes at the beginning of the simulation. We can also specify the exact IDs of the nodes, but this is a very simple scenario. So let's start with this probability here. Then when we have built this configuration object, we can just attach this object to the model that here has been specified as to be an SI model. So we can just set the model here to this configuration. After that, we can select the number of iterations to run, and we can just plot the trend easily in this way to understand what is happening with that model, that data, and that initial configuration. Okay, and this, as you can see, is visualized in trend through time of the infected and the susceptible, or even with a gross number per each iteration of nodes that switch the label from one side to the other. Of course, using the same rationale, we can move from the SI to the SIS, a model which we have a probability to come back from the affected status to the susceptible one, for instance. As you can see here, we have the same beta for the first transition, and from the backwards transition, we will have a lambda that is a similar probability that basically, given the fact that you are infected with probability lambda, you will come back to be susceptible again. So as you can see, same configuration object, same way to run the simulation, same way to get the trend that here are very similar because the initial network is a random network, so the trend in time will not change too much. And finally, just to show you how to integrate a third status in the SIR, you will have two different transitions, one from susceptible to infected, that is exactly the same of what discussed so far, and one from infected to removed, that basically model the fact that once you get some kind of, I don't know, once you get the flu, you can recover from the flu and then you cannot get susceptible again, or other way around, you will die for the flu and then you cannot be infected or be susceptible again. So exactly as before, you can configure the model by using beta and gamma that are the infection rate and recovery rate, and then you can run the execution, run the simulation, and visualize the results. As you can see here, we have three trend line, not two, because we have three different statuses. In particular, the blue one will be the susceptible that will fall down in time. We will have the removed, the green one that will grow in time, and the infected that will firstly grow, and then when the infected will start becoming removed, will decrease in time. Of course, these are very, very simple models that can be customized, personalized, and even rewritten from scratch to cope with a very specific characteristic of the data and the phenomenon needs to be modeled. For instance, just focusing on the epidemic model, the library proposed this different model here that is not all the model that are shipped already within the platform, because this is a quite old list, but you can consider that there are at least now 20 models for epidemics and at least 12 for opinion dynamics already implemented, apart from the model that you can develop by yourself using the functionality of custom models and so on and so forth. So since I have left very, very few time, I just propose you a very quick overview on the Hipmob library. And this is a different kind of library. It's not a network science library, it's a mobility related library. And basically here the idea is that you can load movement data in a data structure that is an extension of the data frames, trajectory data frame. And using this trajectory data frame object, you can compute several statistics. For instance, you can compute the number of points for each individual users. You can compute the trajectory, visualize the trajectory of each individual user. You can perform, most importantly, transformation on the data For instance, let's focusing here on a single user. So what you can do is to filter, compress, and detect stops in the trajectory of each individual users. And this in a very, how can I say, annotated way. So each time that you perform a transformation in your data, the library will remember the transformation that you apply to the data. And basically will provide you the list of transformation in order to make more replicable your experiment. For instance, starting from the original data here, after a filter transformation, there will be the chance user this parameter field of the object, of the trajectory object, to understand that has been applied the filter and which kind of function parameter are being applied. For instance, the fact that the maximum speed in kilometer was set to 500 km/h, that the speed kilometer is 5, and so on and so forth. So these transformations be recorded. So if you are trying to analyze data that have been saved after transformation by others, you will be able to understand which are the preprocessing applied to this data. And let's assume that after a filtering, you would like to apply some compression. If you apply the compression, for instance, reducing the points, agglomerating all the points within a spatial radius of 0.2 kilometers, what happened is that after applying the transformation, we'll see that first have been applied the filtering function as before, and then a compressed function. So you can try to reconstruct from scratch which were the whole transformation on the data. And the same, for instance, if you decide at the end to apply some stop detection to understand which were the places in which individuals stopped in order to split a trajectory in sub-trajectory, for instance. And so you can see that starting from the initial data, first a filter have been applied, then a compression, and then a stop detection with all the parameters in order to understand step by step what has been done with the data. Of course, after each transformation, the data can be visualized in their new shape and can be analyzed. And there are plenty of algorithms that are already integrated within the library, for instance, to study trips, to categorize them, to clustering them, and so on and so forth. I will not dig deep in the detail because contrary to the other two libraries, this is not one of the of mine, so I have not developed them, and I will basically provide you only high-level intuition about it. Otherwise, I will just risk to say something not exactly correct, to be honest. So as you can see, there are plenty of functionality here, like in the other two libraries, to manipulate the data, keep track of the manipulation, visualize the results, and also apply some mining, some extraction learning to the data that you are willing to study. So I think that I can stop here. If there are questions, feel free to ask, or if not, if you would like to have any details on forthcoming libraries, just drop me an email or contact me. I'm available to any kind of clarification that is needed. Thanks.
Thanks, Giulio. I don't see raised hands, so let me wait for a few seconds more. Okay, no raised hands. So thanks a lot. And we can move to the next speaker, which is Massimiliano Assante, again from CNR.
Hello.
Hi, Massimiliano.
Hi, I'm going to share my screen. Okay. Do you see it in presentation mode?
Yeah, we do.
Great. Sorry. So, as Giulio already said in this presentation, we're going to see here a very small tutorial on the method engine and its technologies. So I have a few slides that introduce, what is a method engine in a very nutshell, and the context of the method engine and the rationale. And then I will go to the SoBigData gateway and perform some, say, experiment live. So let's start with what is the method engine. So the method engine helps scientists in performing in silico experiments by supplying precooked method as a service, the ones that Giulio just showed in his presentation just before mine. it performs calculation in a seamless way to the users, and mostly important, it has the capability, the features of gives the possibility to share the input, the results, and the parameters with your colleagues by means of the virtual research environments. In this case, the SoBigData Lab environment that we just saw. What are these features? So it is a user-friendly data analytics platform. It uses graphical user interface and HTTPS access for possibility to execute the methods. So the methods that you see and that you will see in the method engine are executable both from the web application that we were going to see, but we also provide APIs to execute and to repeat the method execution. To each execution, we attach provenance information. I will come back on this later on these slides. But more important, it is possible for you to integrate your own method. So if you don't find a suitable method for your research in the list that is available for you, you can use a dedicated tool that we call method importer that you can use to import your method in with respect to the many supported languages that we have. So how do we guarantee interoperability for the method execution? We use the Web Processing Service Protocol, which is an Open Spatial Consortium protocol, and provide rules for standardizing inputs and outputs for the spatial processing service. But we have readapted it for processes that are even non-geospatial. So the protocol defines how a client can request the execution of a process, facilitate the publishing of processing and client's discovery, and allows data to be delivered across network or uploaded on the server. We already saw that in SoBigData, each user has a workspace, so a cloud storage application that he can use to store his files. And one of the features of the method engine is that for each execution, that is for each computation that is performed on the method engine, a folder, a dedicated folder for the computation is automatically saved in the user private workspace. In this slide, you can see the data miner folder, which is the name of the folder where all the computations are automatically stored for you when you run them. Then the computations, and then you can see one folder under computation called ANI plus measurements, ID and random number. That is one computation that I executed few days ago in my work in the method engine. And if you can see, every computations for each computation, the input dataset and the output dataset are stored along with provenance information for process repeatability. Now, where can you find the method engine in SoBigData? In the SoBigData Lab, where Giulio just showed you. So let's now go on the method engine and on the website. I will stop share and stop share from and see how it works very quickly. Okay, here you can, you see the SoBigData.d4science.org, which is the main the URL of the SoBigData Gateway. You can sign in by using your academic credentials or other, identity providers such as Google, Twitter, GitHub, and so on. If you choose academic, you will find, your university or other login possibility. But let's now just enter. So to enter the SoBigData Lab, you just click here, or you go to the site. and you will find the method engine right next to the method development page that you just saw. We will also talk very shortly about the method importer in the next slides, but for now, let's focus on the method manager. So what Giulio just showed you before is the list of available methods that have been already integrated for you in the infrastructures. So basically what you can do, just pick the first one. What you can do is that you can look for a method, looking for its description, and just in this case, this is ANI+ measurements, which annotates named entities and expect an input text file as input parameter. So what I'm going to do here, this is my workspace. Okay, so I previously uploaded some text files or test file for testing, the ANI+ measurement that comes from Gate Cloud, that is from University of Sheffield, and it is already integrated in SoBigData for you. And I will tell that I want to find, say, the date in this text. I will just click Start Computation. Now the method is being executed in the infrastructures. If it takes some time, you can come back later. You have a link to monitor the computation here, an HTTPS link that you can use to monitor the computation. Here you can see also that I don't know if you can read it, but you can see that the method is being executed on the GAR network in this case. And I also have a link to the equivalent GET request. This is important because with this link, I can, paste this HTTPS link in the browser and basically repeat the same computation with the same input parameters that I selected in the interface. So let's just copy this to show later. Here we can see that the execution has produced an output file. Okay, I don't think you are seeing this, but I'm just copying it now. I'm opening it up. The output is a JSON file that is, it reports the input parameters and the dates that it has found. So this is a simple execution of the algorithm, just to test. Of course, we have plenty of methods available. For instance, we have statistical validation of networks and so on. Even in this case, you see the interface changes depending on the input parameters that the method expects, right? So in this case, it expects an edge list of unipartite binary network as input file. Even in this case, I can select the input file from my workspace. And I can, select the parameters and start the computation. Now you can see, even in this case, the computation is being executed. I can have the link to monitor the computation, and I have the link to repeat the experiment. So while it is executing, let's focus. Okay, this is finished. In this case, I have the log of the computation as output parameters and the output. Let's see one other characteristics of the method engine, that is the check computation parts. In fact, I can check all my computations here, the one that I performed, and I can see the output results for each computation that I ran, the input parameters, and the details of the computation, when it was started, when it was ended, the output, and the operator name, in this case is .val. As I said before, what is it possible to do is to, from here, is to resubmit the computation if you wish. So by selecting the computation and clicking resubmit, I can resubmit, so repeat exactly the same computation of before. In this case, this is, I click resubmit and the computation is being executed again. So I will stop the live demo here, and I will come back to the slide to highlight some important features on this method engine. Okay, so now I'm going to share my slide again. Okay. So let's start back from this, the fact that the computation input data set, output data set, and the provenance information are stored in the workspace. What does this mean? For instance, sorry. Okay, here. So as I was saying, we save provenance information for each computation. What does it mean? It means that, for instance, the provenance is information about entities, activities, and people involved in producing a piece of data or thing that can be used to form assessment about its quality, reliability, or trustworthiness. So we use this prov ontology, which is, and you know, it is in the end, it is, you will see an XML file that is attached to each computation, where you know you are provided with the classes, properties, and the restriction that can be used to represent and interchange this information in different systems and in different contexts. And by making use of the standard for let's say the process execution, by making use of by making use of provenance information for attaching for each execution, and by let's say composing self-consistent computation object, in the sense that, as you saw, we save each computation in the workspace, we are enabling the repeatability, the reusability, and the reproducibility of the experiment that you run on the method engine. And what does this allow? It allows also to, you know, because the workspace support the sharing of folders, this allows to a researcher to share the folder of the computations and to reuse the results of a computations of another colleague. So suppose that I have a colleague that I want to work with, we can share the folder of the computations, and then I can reuse his results on my computations if I wish. And because of the fact that we generate, you know, each method execution can be ran with HTTPS link, we can use third-party software to execute the methods in the SoBigData infrastructures. This is an example, but of course, what you can see, what you can do is also to, you know, get the link from the method engine and perhaps use it in your Jupyter Hub notebook. So you will have the possibility to, you know, use some part of, you know, of the method engine even in the Jupyter notebook. Okay, and I want to just close these presentations with a part that I couldn't present because of you know, timing restrictions. But basically, the way that the methods goes in the method engine is through an importer. So you have your script, you know, in R, Python, C. We also support NIMES workflows. And we have an interface that is called method importer that, through an automatic integration process, creates the interface for you, and it make it available on the infrastructures in the data mine, in the method engine, sorry. And, you know, as I was saying, here you can see a number of supported languages, including Java, Octave, Python, Linux compiled, Windows compiled, and so on. In the right, you can see the easy interface is a sort of IDE, you know, that you can use. to carry out your integration using the method importer. And if you are curious, sorry, I think I lost, okay. And if you're curious and you want to see a video tutorial on how to import a method, there is the SoBigData YouTube channel with the method importer tutorial that you can see. So just look for SoBigData on YouTube. You will find the SoBigData++ e-infrastructure webinar that we did in June, I think, yes, 2020, and you will find the instructions there. And this concludes my presentation. If you have any questions, of course, I'm available to.
Thanks a lot, Massimiliano. I don't see raised hands, so I think we can move on, and then maybe we take questions at the end about the whole tutorial. Thanks again. So the next couple of talks take a different perspective. So they are about responsible data science. And we start with Giovanni Comandè. Giovanni, I can see you, you're there. So the floor is yours.
Thank you very much. Can you hear correctly?
Yeah, we do.
Excellent. Let me start sharing my screen and start the presentation. And you can see it, right?
We see a PDF. That's correct?
Sorry, no, that's not correct. Okay. Well, I might be using it. So I share
now a calendar
on screen. No, okay. There you are.
Yeah, thank you.
All right, thanks a lot. As already was announced by Mr. Casati, I will be talking in the framework also of the project leads, so the Guide Attentive Data Scientist. So in a sense, the title of my short presentation mirrors another project which is associated and linked, deeply linked with SoBigData, the infrastructure, the platform that we are developing. Talking in terms of responsible AI, the whole question is whether or not we can develop a data science, broadly speaking, that is able to cope with gaps in knowledge, in information, in understanding across disciplines. And this is something we are definitely trying to do within the SoBigData community. As you see, the title is making a clear statement, so that this ability to hybridize cultures, it's possible, and I would also add it is needed. Just this morning, one of our training was emerging very, very clearly. So let me spend a couple of minutes, no more, to tell you about LEADS, which is it's a training program, a research and training program, with a number of partners. Part of them, as you see, are like the Scuola Sant'Anna and the CNR are just part of the SoBigData community, and the same in the project with other entities and institutions. So what we are doing there, we are transferring in SoBigData. So we are mapping basically cultural gaps in the dialogue between the issues emerging in law and ethics with the needs of pragmatically needs in the data science. And you saw the description of the beautiful infrastructure, which is under development, but it's already up and running and working. So a number of legal, ethical issues are arising continuously in the use of the platform. So in this switching back and forward among the different projects, what we are trying to do is not only to map, but to actually develop and trying to reconcile apparently conflicting objectives that we find in the EU regulatory framework. Think, for example, I guess I'm pretty sure that all of you have read at least once, at least tried to read the entire GDPR, because it's close to all the activities that you are doing. And you might realize that from the outset, it says that it has two goals: protecting human beings' fundamental rights, especially the right to data protection, but at the same time giving rules to share data, to enable the circulation of information. So these two goals seems, and to a large extent, might be perceived at least as conflicting. What we are trying to do is to reconcile this from a theoretical but also pragmatical point of view. And this is basically done also through the training of our early stage researchers. The reason I just spent these 2 minutes talking apparently about a different topic, it's to state the obvious. There is a large need to develop a common language to assist both data scientists, but not only data scientists in the scientific community, but also producers, service providers, even consumers in dealing with the flow of information regarding to them or with which they are working. Now, if this is a need, I think I should try to give you some simple, hopefully, examples. Okay, I'm just skipping all this part of the presentation and go to one or more. It depends the time we have available. Examples, right? Okay, so assuming that you have already read the GDPR, let's read, for instance, what is the subject matter. As I anticipated, this is twofold. The objectives are, on the one hand, to protect natural persons, human beings, basically, not companies, with the processing of personal data, while at the same time laying down rules relating to the free movement of personal data. Now, all this unfolds in finding what are we talking about. So the GDPR applies to personal data. That is, you have to apply and comply with the general data protection regulation as long you are dealing with personal data. Now, all of us could be somehow confused when we start to find an answer, especially in a legal text, in the legislation. So if you look at it with your own eyes as a data scientist, you start to be maybe a little bit puzzled, because you would expect a very straightforward, clear definition of what is in, what is out. Not that easy when you deal with the law. And the most probably tricky part is the one identified in yellow. So basically, personal data are any information relating to an identified or identifiable person. So far, so good. You can, if you have just my name and my first and last name, that apparently is the most identifying thing, you might not find myself. But if you have some other information, you can indirectly link the name to me, to my activities. For instance, you gather from another source the fact that I am a law professor at Sant'Anna, and then you are done. Through information, you re-identified indirectly me. Now, the real problem is that there is no definition of what means identifiable directly or indirectly. And this is a very crucial point, because if I am not re-identifiable, even indirectly, those data you are processing are completely out of the hook. So let's search for some more assistance in the legal text, right? Of course, I'm just playing the game just with the legal text of the GDPR, although you would have needed to do references to case law, to the European Data Protection Board, and so on and so forth, other policy documents, and more else. Now, if we start to look a little bit deeper, we say, okay, wait a moment, not identifiable. So what happens if we pseudonymize the data? So if data are pseudonymized with one or more of the techniques that have been mentioned actually by previous speakers, you will say, okay, no, that's not at least directly identified. And that's pseudonymization. Now you go and you're lucky, because you find the definition of pseudonymization in the GDPR, number 5 in the list. And reading it, you feel comforted because say, oh yeah, I know this notion, right? So it's just if the data are scrambled, are modified in a way that you can no longer attribute them to a specific data subject, those are pseudonymized. Definition is adding something more, that you cannot reconnect without the use of additional information. But look closer, provided that such additional information is kept separated and is subject to technical and organization measures. Wait a moment, this means two things. First, pseudonymized data, by definition, are the data that the data controller is under its own control. Because if you have a duty to keep separated the re-identifying information, means you have as data controller, the entire control of the data. So it doesn't help that much in the indirectly identifiable, because there are other ways. So you can acquire other information in my previous example, okay? Second element that might be confusing without a larger clarification of legal terms is that the data must be subject to technical and organizational measures. So you turn around and ask to your colleague, data scientist, I don't know, an expert in cybersecurity, say, okay, what will be the technical measures I should adopt to protect this data set so that it's really pseudonymized? And then your colleague will read again and be a little bit puzzled because might not have the right answers because it's not written there. This implies that there is a need of dialogue between technical experts and the legal experts in doing the risk assessment, the analysis, trying to understand whether or not you just need a locker for the room or you need to build a Fort Knox to protect the data. But that's not the end. So let me complicate a little bit your life. Meanwhile, I'm trying to illustrate you ways to solve problems. That's what I hope. So how can I define that when a person is actually identified or identified? Well, referrals, the whereas, the considerando, as they are called in Italians, are not technically binding. They're not part of the law. But of course, they are used to be part of the interpretation of the law. And there is a nice referral, 26, which provides basically a number of tests for us. Let's have a look to it. I've numbered in a scrambled way to illustrate the path. So what we know is already that personal data, data which are anonymous, that is, they cannot be reconnected directly or indirectly to a natural person, they are outside the scope of the GDPR, right? That's what we know. And we do know that to this, the GDPR does not apply to anonymous information, namely information which does not relate to an identified or identified natural person, still the definition. Or have a closer look to personal data rendered anonymous in such a manner that the data subject is no longer identifiable. Is this pseudonymization? What do you think? Any reactions on that? Well, it might look like, but it's not. Here, the meaning is that in playing with the techniques and the organizational measures and the technical measures, we could somehow in a spectrum from identified personal data to fully anonymous, have the ability to move along a spectrum in which there is also pseudonymization. But it's a level, if you want, of safe anonymization that guarantees what? Guarantees a certain level of security. And now things are, as you can see, integrating with all the issues of cybersecurity. So number one, let's see what does it mean, identifiable. And then you have this little test to determine whether a natural person is identifiable account should be taken of all the means reasonably likely to be used. Now, don't be afraid. Jurists use a lot reasonably, appropriate, which are technical terms to give flexibility. You cannot have rule of thumb in this. Otherwise, the GDPR would have been born more than old, already fully dead. And it has still some plasticity for evolution, okay? But watch closer, once again, what the test is saying. To determine whether a natural person is identifiable, account should be taken of all the means reasonably likely to be used, such as singling out, either by, now comes the issue, either by the controller or by another person to identify the natural person directly or indirectly. So what you would read there is that in order to consider data sufficiently anonymous, so unable to reconnect, you should take into account also the risks of other data or other people entering in the picture. So it goes beyond the data controller. Many of you would say, well, that's a third-party attack, right? That's a third-party attack to your data set that you have to reasonably take into account. Once again, reasonably. And how you can assess whether or not it is reasonably likely that a third party, you can assess for yourself to some extent, but how can you reasonably assess that a third party is likely to use something? Well, again, a subtest if you want. Point number 3 in the picture. To ascertain whether means are reasonably likely to be used to identify the natural person, account should be taken of all objective factors. So what follows is just an exemplary list. But now, as I used to say to my daughter, whatever is facultative at school as homework means compulsory. That's at least you have to do that, okay? That's the same here. So the following one, it's not an exhaustive list, but gives a very, very clear to a jurist. I'm sure it's just confusing to a regular data scientist without the dialogue and the training I mentioned before, because you have to take into account what are the costs of the amount of time required for identification, taking into consideration the available technology at the time of the identification, which gives you the reason for appropriate, reasonably. What costed X 1 month ago in terms of trying to hacking your data set, today costs X minus something, or takes much less time, or there is another cheap technology which is enabling that. So at the processing and the technological development. Now, if you're thinking in terms of costs, you cannot look at it only in terms of how costly is the technology, but you should, under the GDPR, should always take the lens of the data, the personal data, and of the data subject. So let me give you 2 stupid examples to understand that, and I understand I will not be able to do the other 2 examples, but there will be other occasions. First stupid example. You have a data set with genetic information about a nobody like me, right? Those information might be absolutely useless. Okay, you pseudonymize, you divide all the information, or a clinical trial, you fully pseudonymize according to the definition, and you, for instance, give to a third party lawfully, and just you are sharing the fully anonymous for the recipient information, okay? And at this stage of the analysis, the data you are sharing are just regular health data, worth whatever they are worth. then suddenly you discover that the individual to whom those data belongs has a special characteristic that enable the production of supercells that can give rise to a production, a cell line, which is incredibly perfect to develop highly costly pharmaceuticals. So from worth a dime to cents, that information, who the hell is that person, right? Rises immediately from 2 cents to, I don't know, 20 million, 200 million. So just the value of the information is changing, whether those data have enough protection to be reasonably the means, to make reasonable the means used to hack your information. Second stupid example that would lead me to the third example, but I don't think we have the time to do it. Let's assume that you are you're subscribed to a www.flink.eu or .com. That is a website in which you are searching for partners for one night stand. And the website is it's a Flink only for people who are married, right? So as long as you are married, you can apply and search for a one night stand partner in the website. Now, re-identifying you as belonging as one subscriber of that information, if you look with the lens of the institution, the owner of the website, clearly you pseudonymize, you don't want to know going with whom, and you would want to protect the database of your customers for a number of reasons, and you can minimize the risk accordingly. So this is leading to the data protection impact assessment. What I'm right now describing, it's a regular risk analysis, common methodology, seen with the lens of the institution. When you see the data breach with your lens, okay, now you all subscribed to the www.flink.com. Assuming you have a partner, a permanent partner, I'm assuming you would not be very happy to know that your partner can be informed of the fact that you subscribed to a website to cheat on them. From your perspective, the value of that information, what is changing, affecting in your life as a different dimension, right? And that changed completely the point of view. And the latter one, the one of the data subject, it's actually the perspective which is requested, but not yet deeply understood, especially in practice, on the data protection impact assessment. Because the key point is the risk to the rights and freedoms of the natural persons involved. It's not a matter of the institutional analysis, which normally takes also into account the risks. But for instance, if the risk is someone is killed, this can be technically and lawfully in a different setting internalized in terms of insurance. You have a liability insurance. Here, you can't. You can do just that, all right? But I think I've been saying too many things. There are a number of other examples going to the other part of AI, but I will stop there, just showing you what you are missing, and thank you all. Of course, I'm available for questions and criticism, suggestions.
Thanks a lot, Giovanni. Do we have questions? Okay, not yet. So maybe later during the Q&A. Thanks again. And the next talk, thank you. The next talk is by Francesca Pratesi on FAIR, the learning module for GDPR compliance and ethical aspects.
Yeah, thank you, Chiara. Good afternoon to all. I'm Francesca Pretesi, and as a computer scientist dealing with developing on privacy-preserving methods to exploit data, I often need to translate the principle that Professor Comandé just told us from a technical perspective, so in a technical point of view. So this is indeed the topic of my presentation. So let me share my screen. Okay, so first of all, I will only give the introduction on how we operationalize the pillars that guide us as a project. So starting from the beginning, from the SoBigData previous project, so the one that Roberto Trassarti told you. So we try to develop this pillar that guides all the researcher in the developing on this platform. So first of all, we think that probably the most important things is to inform both researcher and public community in order to create awareness of what are we doing with what kind of data for what aim. So in order to try to develop trust. This can be done critically question all the choice that we made as a researcher, and also the trade-off, because of course there are trade-off between privacy and utility, between fairness and privacy, between all this kind of dimension. There are this tension that need to be public discussed. And this is related to the other point, the fourth point, which is informed data subjects. So all the information that we have in our data catalog need to be publicized in order to be sure that all the data subjects, even if they are not directly recognizable in the data, are informed about the use that we are done with their data. And then, of course, to apply privacy-preserving techniques as long as possible, as soon as possible. In order to try to translate this principle in practice, we developed this online course, which is named FAIR, First Aid for Responsible Data Scientists. You can try it on your own at this link, fair.sobigdata.eu/Moodle. But now we will see a very brief demo of this module. So once you arrive to the landing page that I just said, you will have this page. You need to register in order to access this course, but we only need a very few information. Some of them are not mandatory. We only need essentially your name and your email in order to access to this website. And then, of course, you are free to give us other information such as your city and your country. Then you will select you can select the first and the main course, which is the only available at the moment, trying to give you an idea of what are the basic concepts, in our opinion, in order to develop and to use method that dealing with personal data. So this is the main page of this course. As you can see, in our objective, these are the three topics that we develop. So first of all, we would like to give you an idea of our ethical vision. Essentially, we go in deep to the ethical pillars that I just told you. And then we want to give you an overview of the GDPR. What are the basic definitions that you need to keep in mind in order to deal with data. And then some idea of the intellectual property rights with a special focus on social media content, on social media platform. So you have a glossary also that can be accessible, where you can find all the definition, a summary of the definition that are used in this course. And each unit have a part which is the theoretical part and a practical part. So in some case there are two kind of practical tests, but essentially there is a multiple answer quiz that can be answered multiple times, because our aim in this course is not to test you, not really to test you, but it's to create awareness. So it's a sort of self-assessment tool, and you can redo, you can check. We will see in a while how the quiz work, but essentially you have this part. Sorry, I reached the end in the previous presentation. So you have this slide information. You can go through the lesson in a consecutive way or skip directly to the part that interests you. And once you reach the end, you are encouraged to take the quiz. So as I told you, you can redo the quiz any number of time you want. You can do to the following lesson, okay, or you can reattempt the quiz if the result is not good for you. So in this case, I don't want to read the question, but I want to point out that you can check each question directly, so in real time, and then now I select two good answer, but the important point is what happens when you select a wrong answer. No, in this case, sorry. In this case, nothing happened, but otherwise you are, in some sense, guided to understand why the answer that you gave is not correct. And in other cases, you are forwarded to the specific part of the course that dealing with the particular information. So that in this case, for example, your answer is correct, we suggest to take a look to the lesson, and you will send to the right part of the lesson, of course, that is dealing this specific question. So at the end, we can also not check all the question, but you can revise all the answer once or at the same time at the end, and you will receive the same kind of feedback. Once you finish the review, you are mandate to this page. This was my previous attempt. In this case, I reach a score which is very low, which is less than 1 out of 6. So you are encouraged to take again a look to the first question. Otherwise, you are sent to the following one. Once you have all these 3 lessons and all these 3 quizzes, it will produce a certificate that you can download and keep for your record. And then the last point that I would like to provide to talk you is that we also provide this research part. So all the documents that we think are fundamental to understand and to go more in deep to specific part for ethical and privacy, and of course also the deliverable of the project related to the ethical concern. So this is more or less the overview of this course. Of course, we would like to provide other content in the future, and feel free to suggest us something, or of course to ask me anything you want here. I'm finished. I like to stop sharing.
Thanks a lot, Francesca. You are done, right? You don't have other slides. Okay. Okay. So I think you gave a great overview of the SoBigData++ platform. So we had 2 introductory talks, then we went more hands-on, and then we tried to take the perspective of doing responsible data science, which is something that is often difficult to grasp for computer scientists in particular, because as Giovanni was saying, it's not very easy to understand what is the reasonably what is considerable a reasonable protection of data, and to assess the value of the data that we store. Having said this, I think that we are now open for questions, I think. So Beatrice will not be here, right?
No, we will organize ourselves.
Okay, that's perfect.
So for any question, discussion, I mean, point of view, I don't know.
I see a raised hand. Okay, Alessandro, you can mute yourself and shout your question.
Yes, well, thanks a lot for all this information. I think it's really, I was not aware of how broad and how deep all what you're doing is actually is a great work, really. Well, as you know, I actually come from the AI for You platform, so I really look forward to connection between the two things. One thing I like to understand, though, not in the context of AI for You, but in the context of Humane AI Network, is so what's your relation with Humane, or your planned relation with Humane AI Net? Are you going to actually offer this infrastructure to people in Humane AI Network to use it as it is, or are you actually planning of changing it, modifying the infrastructure, customize it in some way to make it more apt or suitable to the needs of Humane AI Net people? And how are you going to do it? How are you going to know what are these needs in this case?
So okay, let me say that what we thought about a possible collaboration with Human AI Net is to, first of all, I mean, engage the community, your community of researchers, in order to use our tool as you want, and give also the possibility of starting, let's say, collaboration from the research point of view, in order to produce new tools that will be published on the platform. So in some sense, to give the possibility as a normal user, let's say, as normal users to all the community of Human AI Net. A second possible step, I mean, a more, let's say, deep collaboration may be the construction of specific virtual research environment for Human AI Net, for example, where a virtual research environment, I mean, Massimiliano cited it before, but let me repeat it shortly. I mean, a virtual research environment is a place where a specific community may work and exchange data information and may publish slides, let's say, even to the public, the results, for example. So be a sort of, front page, let's say, but not as a classical web page, but becoming part of the research infrastructure. So in taking advantage of catalog for what your methodologies, storage for your data, and also the computational power that can be useful to exploit the tools, the algorithm that you can integrate. For this also, you can think that even for us, I mean, inside SoBigData, we have different level of integration of our tools. So we can put them in a catalog. The easiest way is to put it in a catalog as a resource, let's say, stored somewhere, maybe even in the platform, but as an external tool, let's say, to be downloaded, executed, and whatever. there are a more even here there is a more deep way to integrate and so to collaborate with the research so SoBigData, integrating the methodology inside our platform in a way that people may use the lab as Giulio shown to you, or the engine that Massimiliano showing to you, in order to experiment with the tools. So people may register, enter, and execute an algorithm developed by one member of humanities on the server of SoBigData and getting the results. So let me say that we need to talk about it and discuss about it, but clearly there are several levels of possible integration that may be explored. The bigger one, let's say, maybe also that humanities may be interested in, let's say, building its own, let's say, view of the research infrastructure, as we have done, for example, for one of our member, which is University of L'Aquila, which is at its own, let's say, research infrastructure called Territori Aperti, open territories, where, I mean, everything is included inside, let's say, that particular instance of research infrastructure, and you may choose to share with the SoBigData the catalog. I mean, finding things of SoBigData there, or vice versa. So all those possibilities are open, and we need to understand. I mean, open, and we don't even need to choose only one of these. Maybe we can mix them up, but for sure, I mean, it's a possibility. I don't know if this answered to your question.
Yeah, definitely. So if I understand well, anyway, you don't have plans, and of course understand that, to say use also input from humanities to add new features or to modify in any way the infrastructure to say to broaden the scope of the type also of users. And for one thing, for instance, I mean, is the current infrastructure, of course, is very much biased toward data science and data analysis. In human AI net, there are a lot of people working with other types of AI, with symbolic AI, planning, knowledge presentation, and whatnot.
Let me say that when we spoke about the virtual research environment, we can speak about one of our exploratories. So if the collaboration and the input of human AI net is let's say so much, and so let's say we are so much interconnected that may becomes a new exploratories, for example, which actually become a new chapter. I mean, a new vertical context that we consider, or I mean, maybe part of the explainable AI. I mean, the fundamental structure of the RI. The research infrastructure is that one, let's say, but the content of the research infrastructure may be changed according to other contexts, other community that are engaged with us.
Yeah, and also to complete, of course, we also considering some specific feature for our stakeholders to integrate. We continuously update our research infrastructure also for the need of our stakeholders. In this case are our beneficiaries, but in the future could be also external member. This is of course, also from the technological point of view, is not stable or well defined. We are currently continuously update, and if we need, for example, also the integration of Jupyter Hub was one last thing, is what not available since 2020, but our community said, okay, we need some of these tools, and we integrated. So also this kind of iteration helps us to improve the services related to our research infrastructure, and also to try to be more attractive also to other projects. Yeah.
If I can jump in here, so I'm not sure it's maybe entirely clear to the people in the audience to which extent we can use the SoBigData platform, for example, to run experiments on data and algorithms that are typical of artificial intelligence. So is it safe to say that as long as I can write a Python notebook, I can run it on the platform, or there are some constraints, things that cannot be executed as they are?
So I think that I will pass this question to Massimiliano. But no, in general,
It's
yes.
fair. Okay.
Basically, we don't have any restriction.
Yeah, no. I mean,
we
don't.
are not talking malicious.
The restriction is more. I mean, for now, we give to the public a certain power. Let's say to the virtual machine that are created for the Jupyter Hub. So you have now, if I well remember, it's 2 cores and 2 GB, but it's really open to everybody that enter to the platform. In the case of collaboration, we can create a specific virtual machine with more power if it's needed, something like that. I don't know if Massimiliano, you want to add something about it?
Yes, I just want to complement that for SoBigData, it's being say by exploiting different science, it inherits the capability of creating virtual research environments on demand very quickly. So what you saw in SoBigData Lab, the virtual research environment SoBigData Lab, could be achieved for human AI net within really, couple of days, couple of working days. So we could replicate an environment similar to SoBigData Lab, but restricted, to your, let's say, your project, and in very short time, where you can integrate and start, playing around and see what is the potentiality if it's needed. Clearly, the limit was the computational power that we can provide. We are not Google. Yes, of course.
So actually, we are trying to give as much as possible, and we are planning to extend also the next mid of next year the computational power that we can provide in the lab. But yes, I mean that's it.
If I may just add to this and relate to the previous question by Alessandro Saffiotti, I think it's a very good linking point is that HumaniAINet is willing and aspiring to develop trustworthy AI. And the kind of work that we are doing, it's an ongoing work, expansion, as Francesca was mentioning in her pilot test and course. We could, as a platform, as a growing platform, also growing from the legal and ethical part, be to a large extent an assistant in the development. If I go through the list of the members and participants of the INET, I think that this cultural link and compliance, if you want, sustainability for trustworthy AI, it's not apparent, at least. I'm not saying that it's missing, but it's not as apparent as it could be, and that's where I see a large role for a sustainable partnership as well.
Thank you. Very good point.
And sorry if I go forward, then I stop, just to make sure I understand. And of course, I understand all the code and everything technically is open source. So in fact, if somebody from the Human AI Net consortium, for instance, wanted to probably together with some of you create such VRE, probably it could be arranged without any sort of pragmatical, legal, or implication. I mean, it should be a sort of simple thing to do from a practical point of view, right?
Yeah, I mean, from the practical point of view, it's pretty simple. Actually, you can decide if everything will be public available or restricted to a certain number of users, or I mean, there will be, when you have a VRE, actually you have also the management of that VRE. So you have a manager of the VRE who can decide who can access to it, or if you want to have something completely open to the public. I mean, for example, in SoBigData, almost everything is completely open to the public, which is different from saying that everything that to put in the catalog is freely available, in the sense that publicly available. Because, for example, for some data set, we put an item in the catalog specifying that that item is this giving a description of that item with the metadata, etc., but without the possibility of downloading directly from the catalog, because I mean, maybe it's a data set with personal information or something like that, and clearly at that point it's someone can understand where is that data set and maybe start a collaboration with and going through the ethical committee, for example, to understand which is the objective of the analysis. So even there is the possibility of understanding. There is the possibility of deciding which level of availability you want to put, online, not online, completely restricted. So clearly the world is a very there are very different situations, let's say, in the data world, especially in data world.
Thanks a lot.
I have a very quick and practical question. So if people from the Humane AI Net project, they want to play with the SoBigData platform, so they go to the SoBigData gateway and they can enter, right? No special authorization needed.
They should register, because we need to keep trace of the people, but it's completely free.
Okay.
And yeah, that's it. They can go play.
Perfect.
I mean,
yeah.
go there and register.
Register and then play.
We hope that you not only play, but you use it.
Yeah, sure.
Yeah, register with
also
play.
in your research every day, not only for play, but also for improve your production and quality of your science. Of course, this is our main aim.
Yeah, I agree.
Yes, if I may just add just a bit of information. SoBigData Lab is free open, so you can enter, but has limited the resources, as Roberto said. So instead, if we create your own virtual research environment, so we could allocate much more resources, for instance, up to 32 giga, per notebook instance. So, of course, the free issue is,
Thanks, Massimiliano. Yes, clearly, I mean, the one that we can offer to the public, it's more limited because there may be too much otherwise. That's it.
Okay. So the message is think about if you as Humane AI Net Consortium want to have a VRE where you can exploit more resources and computational power.
May I then ask a follow-up question? If we, now I'm wearing the Human AI Net hat, if we really think about that, of course, the question would be sustainability. So what do you expect to happen with this platform in the long run? Who will manage it? Who will own it?
Oh, Yeah, it's a good question. Not always we receive this question, because, but actually, no, we enter now. I mean, the SoBigData++ project will end at the end of 2024. And this is the European project. But actually, we entered now in the S3 roadmap. So I don't know if you know what is S3, but actually it's a selection of research infrastructure in Europe, and this program will guide, let's say, the research infrastructure with additional funds and assistance in order to get sustainability. I mean, in a very long run, we are talking about 30 years, something like that. In particular, I mean, there is this process will lead to get funds less from European project and more from local country. I mean, the countries a financial sustainment for the countries which will be part of a legal entity. So practically, the idea is to become a legal entity at the multinational level and be sustainable in this way, selling, let's say, at a certain point, to selling also the services that for now clearly it's free because it's paid by the European Union. Let's say this is the general idea. We hope to become a legal entity and be sustainable in the next future. We are trying.
Yeah, the idea is to work until 2050. So
yeah,
we should not have any sustainability problem.
Should.
Okay, we are running 15 minutes late, so unless there are other quick questions, I think we can wrap up this tutorial. I don't see raised hand, so I take that as a no for additional questions. So I would like to thank again all the speakers from the SoBigData project. It was amazing. I mean, we learned a lot of things, and that we hope we can exploit within the HumanityNet consortium. The tutorial has been recorded, so if it's fine for all the speakers, we might share the link to the video with all the registered participants and within the HumanityNet consortium. So if you have problems with that, just drop me an email, okay? Okay, that's it.
Thank you.
Thanks again.
Thank you. Bye-bye.
Bye-bye.
Bye.
Thank you all.
Thank you. Bye-bye.
Thank you, Chiara. Thank you, everybody.
Thank you. Bye.